Today's webinar is a masterclass on EC2, the Elastic Compute Cloud. And the purpose behind these masterclass webinars is that it's a technical deep dive beyond the basics. So in 45 minutes, the aim here is to expand your knowledge, educate you on some of the deeper features in the technical service of EC2 and how you can get the best from AWS technologies and show you how things work and get things going. So 45 minutes isn't a great deal of time for this topic because EC2 is hugely expansive and it's the core of every compute application that we put into AWS. But we'll try and get you as deep as possible as quickly as possible. So Amazon EC2, what is it all about? I mean, it's obviously an on-demand compute to run application workloads, anything from web applications to back office applications, data processing, analytics, and so on. And the core of it is that it's a disposable resource. And we'll talk about how you architect around EC2 to take account for that disposability, because it's an easy come, easy go kind of platform. You can spin up compute and you can drop it and stop paying for it as easily as you acquire it. And fundamentally, it's about us providing the infrastructure to you and then you deciding what you run upon it. So this masterclass webinar is going to give you some tips and tricks on how you can wield EC2 and how you can use it in conjunction with some of the other services like Elastic Load Balancing and Autoscaling, so that ultimately your workload, you can decide what you run and how to perform your application workloads on EC2. So what is it at the top level? Well, fundamentally, it's about complete control, as I've just said. You get to choose what you run on your compute. You acquire instances of virtual machines from which you can choose the OS that's running there, and then you have complete root or administrator control about what stack you install on top of that instance. It's flexible in the terms that you can choose the instance sizes you wish to run. You can start at very small instances and you can go to very large instances. You can change those instance types as you go through, and you can choose the OS builds that run on top of them. And ultimately, it's this elastic capacity. You can have as much of this, or as practically as much of this stuff as you like. So if you need to grow from one server to many thousands of servers, you can, because we have the resources available to you on demand. Some things at the bottom then is that we've got some built-in security features that we'll talk about throughout this webinar in terms of it integrates with our security groups, which are part of the host firewalls on our hypervisors. It's inexpensive. It starts at a very cheap price point for small instances, and it's reliable. Okay, and it's built around technologies that enable disk volumes to be reliable, the EC2 instances to be reliable, and so on. So drilling down into elastic capacity and then getting into the technical nitty-gritty of how this thing hangs together. So it's a shared environment. So everything that's run in EC2, you could be on a physical host with other customers. And it's securely segregated. And it's worth stepping through how that works and the infrastructure that we use. So shown on the right is a logical diagram of a physical host within EC2, where many customers can reside. They're shown as customer 1, 2 to N. Now, we base our platform upon the Zen hypervisor, and we are active in the Zen community, and we take the Zen hypervisor and build our hosts upon it. And that ultimately gives you the workspace in which your virtual machines run. So under that hypervisor, we then present virtual interfaces that enable the networking to and from those virtual machines. And then at a host level, we have a firewall within which customer security groups or your own firewalls, virtual firewalls, run. And then ultimately we have a physical interface to the outside world. And of course there are many, many of these hosts across our facilities across the world. So if you think about traffic, and traffic is securely segregated via that firewall into your security groups through the virtual interfaces controlled by the hypervisor into the workspace. So every customer is securely segregated, and we take great lengths to ensure that this is technically audited, it's badged against a number of security standards and so on. But fundamentally, it's a shared environment where you are segregated from other customers. Now, there are other constructs within EC2, such as virtual private cloud, which give you control over fundamental networking in this environment. But we're not going to focus on VPC today. We're going to look purely at EC2, and then you can build upon that knowledge and go look at VPC later or come and see one of our masterclasses at another time. So let's introduce some terminology then, so that we're all talking off the same book. The first thing that we'll introduce, and we'll come back to a number of times, is something called an Amazon machine image. So an Amazon machine image is a golden master, a freeze-dried copy, if you like, of an instance, a virtual machine. In a running or stop state, you'll create an instance from an AMI. And there are various different flavors of AMI, such as community-based AMIs, Amazon-based AMIs, and I'll touch on those in a moment. But you create an instance. So this is our term for a virtual machine. An EC2 instance is created from an AMI. And then it's that instance that you're choosing to launch in one of two ways currently. One is EC2, which is what we'll focus on today, and the second is in a virtual private cloud, which gives you more control over networking constructs and has some slight differences in terms of instance addressing. We'll ignore VPC today, but be aware of it. It gives you an extra layer of control at the networking layer fundamentally. You launch an instance into an availability zone in a region. So a region is an isolated set of AWS data centers, such as EU West, or we have US East. There's a number of them. There's 9 of those regions around the world. And within a region, we have 2 or more availability zones, which are collections of those data centers that make up a region that are physically distinct from a power, from a floodplain perspective, and a networking perspective. So you can launch EC2 instances across multiple availability zones in a region. Within an availability zone, we then have something called Elastic Block Store, and this is a disk drive that underlies your EC2 instances, and we'll drill down into storage and block storage throughout this webinar. But those EBS volumes, your C drive for a Windows instance for example, are stored within an availability zone, and they are redundant within that availability zone. So your data is copied twice at least within that availability zone to ensure you've got reliability of those volumes, but it's not across availability zone. So if you think about launching an EC2 instance, you're choosing, if you like, the virtual data center that runs in the availability zone, and you can be sure that the disk volumes attached to that instance in that availability zone are reliable. And then you can spread resources across multiple availability zones, multiple virtual data centers, and build up within a region a high availability architecture. Some of the things that integrate then with regional services, so we have S3, our simple storage service that enables you to store objects from 1 byte to 5 terabytes with 1190 durability. There's an S3 Masterclass YouTube video that you can look at if you're interested in that. Snapshots, backups of volumes, for example, are then stored within S3. So we have EBS snapshots in S3, so they're stored reliably within the region. And then you can recreate volumes, you can create backups, so you can restore from those backups into the EBS, and therefore you've got a management platform for your disk drives underlying EC2 instances. So that's the basic terminology that we'll come back to a few times throughout this presentation. AMIs, instances, EBS volumes, and EC2. So let's look at the instance itself and understand some of the properties of it. And I like to think of these as 3 things. Your instance in AWS is a unit of control, a unit of scale, and a unit of resilience. And it's useful to think throughout this webinar of if you like, divorcing yourself from the physical nature of traditional servers, because EC2 is a resource that you can acquire very easily and you can dispose of very easily. And as such, it genders a different thinking about how you architect or how you treat compute, because treat it as just as you would instantiate an object from a class in a piece of code and then destroy that class when you're done with it. You can treat compute in the same way. So a unit of control, I think of this as embodying your stack of software, the components that you need to run your application, whatever that workload is, and the OS and the machine specification that you might need to run. You can bundle that thing as a unit, and it could be as simple as a Node.js server. It could be as complex as a SharePoint application. And you can bundle those things, and your stack then becomes a unit of control, where you want to deploy it, when you want to deploy it, how many you want to deploy of them, and ultimately how you spread those around the world for availability and architecture and so on. So your stack, your control, and you can choose, for example, the instance size that you run on it. You're controlling the cost of your application by taking an instance as part and parcel of your application stack. It's a unit of scale because you can spread these things out thinly. You can have many of these resources, whereas in a physical world you might be constrained about the number of machines you actually have to do a job. You can scale out very easily in EC2, and you can even play with the cost dynamics because you can spread out on smaller instances wider get high availability as a result, but also save yourself money in the bargain. So a unit of scale is EC2, and a unit of resilience, because as you spread things out, you can obviously then become fault tolerant, you can handle instance failures, and using some of the automation features that I'll talk about in this webinar, you can then replace that instance, and it becomes a unit of resilience or self-healing. But that brings me into instance types. Okay, so one of the fundamental things to understand is the family of instances you can choose from. Because, okay, you understand what it is. You might want to go and launch a Windows instance or a Linux instance. What size instance should you choose? And now here's a rather eye-watering diagram, and of the number of instances that AWS currently has. We're constantly adding to this family. We're adding everything from high memory right up there at the top right in white and red, where we have 244 gigabytes of RAM on an instance with 16 virtual cores and 240 gig of SSD. Or right the way down at the bottom left, we have the small red one, which is a micro, which is 2 elastic compute units, 613 megabyte of RAM, or kind of like the equivalent of an iPhone 5, I would guess. So there's a range of families of instances in between that do different types of jobs, from those at the top right that are in high performing 10 gig fully bisected networks for doing cluster compute and shipping lots of data efficiently between large instance types, to ones that have proportionally higher memory to CPU versus those that have higher CPU to memory. And there's all sorts of different flavors here, so you can choose an instance that matches your workload. But one of the things that I would always say is that start small, because within EC2 it's easy to scale up your instance type. It's a simple right-click, resize instance in the console. And psychologically, I've come across this a number of times with engineering teams, is that what will happen is if you start large, there's a reticence to then downsize for cost efficiency reasons, or to check that you're being, using the best use of resources. Whereas if you start small and things don't perform very well, it's very easy to go up, and you'll sort of find a better balance in that way. It also engenders this idea of sort of late binding, because what you really want to be doing is taking your application stack and everything that runs on the OS and then choosing at the last minute what sort of instance it runs on. Because if you're divorcing yourself from that sort of decision, the sort of last minute, you can always take advantage of the latest instance type and get the biggest bang for buck out of your workloads on an instance. It's easy to size up, so start small. Now earlier I mentioned AMIs, so there are 3 broad categories of AMIs. So when you launch an instance, you'll get to choose one of these sort of categories. The first is Amazon maintained images. So we have a set of Linux and Windows images, we keep them up to date, and there are AMIs in each region that you would choose to run from. So for example, in the EU, and you choose to run a Windows server, it will be a slightly different AMI from the one in US, because it's a European distribution of Windows. There are community maintained AMIs, and these are published by other users. They're managed and maintained potentially by marketplace partners too. So we have a marketplace where vendors can publish AMIs, and then everyone has the ability to share AMIs with everyone else. So marketplace are kind of a trusted place to get community assets from. Whereas in the user shared environment, you might want to take care and attention about what's there. They may be really handy for getting you going, but you may want to consider what was on that AMI and what was built into it in the first place and whether it really meets your needs. Then of course there are your machine images. So you can create AMIs from EC2 instances that you've built and configured, and you can keep these private to yourselves or share them with other users or other accounts. So you might have other people in your team, you might have other accounts within your company, and you can share that and build golden masters. Now, the use of AMIs in your context is something I'm going to come back to as a key part of understanding at a deeper level how to really wield EC2 in a dynamic environment. So I mentioned that AMIs are, have defined published ones by Amazon, and here is a list, and you give, for example, for Amazon Linux AMIs, you can go to that URL at the top, and here's a list of the AMI IDs in different regions for different types of instances running Amazon Linux, whether it being an elastic block store backed 32-bit instance, or far right, whether it being in a couple of regions where you can run cluster GPUs with NVIDIA cards in them, a 64-bit backed machine. So configured OSs to handle the different types of hardware that is running underneath these different instance types. So if you look at the AMIs themselves that we maintain, and I've chosen to ignore the micro here and go for a price point on a small instance. So just looking at the left, we have sort of our Linux and Ubuntu. So a small instance from 6 cents per hour. This is a on-demand pay-as-you-go price for running that sort of distribution. Whereas in the middle, we have enterprise Linux variants. And you can see the prices are different from, say, Amazon Web Services Linux. And this is because the hourly price includes the license for running that particular OS distribution. So whether you're after SUSE Enterprise or Red Hat Enterprise, you can choose to launch those from a maintained set of AMIs and know that the license is included for those distributions. Likewise with Windows Server. So Windows Server from 11.5 cents per hour, license included. You don't have to worry about the license of the Windows software, but you of course then the applications that live on any of these distributions, if they come with some sort of licensing constraint, that's your responsibility. Just another point on sort of economics, just so you understand instance types. So I've just mentioned on-demand instance types, and here we're saying a micro starting at 2 cents per hour. This is a price that you pay when you acquire an instance. You choose your instance type, you choose where you want to run it, and you'll pay a price per hour for that instance. So the classic way of dealing or interacting on getting an on-demand EC2 instance. You can also reserve instances, and this is a really important step because it's a great first step in cost optimization. Because let's say you're running a server that is always on, it's 24/7, and you're paying the on-demand price. You can actually reduce your overall costs for running that instance by paying an upfront fee, and that upfront fee will depend upon whether you take a 1 or 3 year term. And what you're buying is a billing construct. You're choosing the instance type that you're running, the availability zone and the region and the distribution of that you're running of the OS on top of it. And if you're running any of those instances at that point in time, you will then get a discount on the hourly rate. Okay, so you can save yourself, and it pays back really quickly, actually 6 or 9 months depending upon the 1 or 3 year term. And there are different types of these because depending upon how often that machine is running, you can buy different types of RIs. So if it's running all the time, there's a heavy utilization RI, so you get the maximum saving, but we're assuming you will always be running one of those instance types, so you'll always pay for the RI whether you're running an instance or not. Versus medium and light utilization. So if the things are turning on and off overnight, maybe you might consider a medium utilization RI, and the price points and so on and the cost, the savings come into play there. So if you're interested in those things, reach out on the contact us form and we can get in touch with you. Lastly, the spot instances. So this really epitomizes disposable compute, really, because this is about getting access to EC2 resources, the excess capacity, if you like, in the cloud for a particular instance type at a far reduced price. So where it's underutilized, the price you'll pay will be far less than the on-demand price. There's a supply and demand thing going on. And you bid a price you're willing to pay to acquire that particular resource. Now, if you think about your workloads, some workloads are perfect for this. So there might be batch processing workloads that are feeding off a queue where you need instances to spawn up. You need them to consume some data, do a job, and then you're happy for them to go away. Media transcoding, for example, is a great example. You could be doing Hadoop, big data analysis, where you're parallelizing very large data sets, and actually very fault tolerant as a nature, that sort of framework, where instances can come and go. If you've got that sort of workload where it's not needing to be run 24/7, spot instances are a great way of saving a whole bunch of cash. But be aware that if your bid goes below the market price, your instances will be terminated. So it starts making you think about architecting for disposable compute and compute that can come and go. Alright, so that's kind of the background on instance types and a bit of flavor about the pricing models you can put around it. Let's go then one step deeper and talk about how we launch an instance. Look at some of the commands that we can use, concepts such as key pairs and security groups, so you're completely familiar. So you can go into the console and you can launch using one of 3 different wizards. An instance, you can choose to use a classic wizard, a quick launch wizard that fills a load of stuff out for you, or you can launch using the marketplace wizard where you can select some stuff from the outside world and it will pre-configure things like security groups and assets on those instances as it launches. And you can easily go through that, and the core things that you need to know when you're launching an instance are here. So one is where you want to launch it, the region within the AWS network that you're launching into, such as EU West, such as US East, and so on. The instance size that you wish to launch. So this could be an M1 small, it could be a cluster compute, and all our instances have a particular API name that are listed on our documentation site. The Amazon machine image you're going to launch from, so whether that be one of ours that we maintain or indeed one of yours. And then two things at the bottom here, key pair and security group. So key pairs and security groups are controls in which you can imply to how you access your machine and how that software running on that machine is accessed over a network. So authentication for a human to log on, and then firewalling, security grouping around the instance to control the traffic. So key pairs are something, let's just talk about key pairs and distinguish them from some of the other things that we have in AWS that sound a bit similar. So when we launch an instance, a couple of things happen, but the primary thing around key pairs is that a public key portion of a key pair that you generate within the console or via the APIs is inserted into your running instance at launch time. So the EC2 instance receives your public key as it's launched. And thereafter, if you wish to access that instance, you need to use the private key that you received when you generated your key pair in order for you to be able to access that instance. So you can't, for example, in Linux, SSH onto an Amazon Linux instance without your private key. When you're doing Windows, the process is similar in that the public key is inserted into the EC2 instance running Windows, but then that public key is used to encrypt a first-time random Windows administrator password. That's then passed out via syslog, and then you use that private key to unencrypt that password so you can RDP onto that instance, and then you can configure that box. So a similar thing about securing first access onto the instance. So key pairs on the left end are used to authenticate when accessing an instance, versus some other things you'll come across within EC2, particularly when you're using APIs or command line tools and so on, versus something called credentials. So credentials is an access key and a secret key used to authenticate against APIs. So this is if you're using command line tools to launch an instance, for example, or using our auto-scaling tools to manage auto-scaling. You'll have these two things that you can download from your account, a shorter and a longer string that will then be having to pass in to all of our API calls so that we know who you are and we can check that your account is good and valid. You'll also find some of the tools use X509 certificates, and this is a bit of a heritage, so a similar sort of construct, a key pair using to authenticate against some of the APIs, but you'll find that most of them now are standardizing with the use of access key and secret key for the credentials to access APIs, and this is very distinct from key pairs, which are used to actually enable administrator access to an instance. So think of credentials being used by code deployed on EC2 instance to access APIs such as S3, and the key pairs themselves being used by admins to access the boxes to do some sort of administration task. Next up then is security groups. So security groups are instance firewalling. So as you launch an instance, you'll be asked to choose a security group to apply to. So by default, EC2 instances come up as lockdown, so no access. You need to open up something. And typically, let's say you're launching a web server, and you're going to open up port 80. It's an inbound firewall rule, essentially a security group, and port 22 to allow SSH so that I can log on to this box, I can configure this instance, and port 80 is going to allow web traffic in to be served by a web server running on that instance. Now you can add many instances to a security group. You can modify security groups. You can authenticate one security group to talk to another, as well as adding IP address ranges and port ranges. So an inbound firewall is what that is, a security group. VPC slightly differs. It adds more features to security groups. And if you want to learn about that, I'd suggest you have a look at the documentation or come and visit our VPC webinar that we'll be holding in the future. So take a look at this then. So this is PowerShell. We've got some PowerShell tools for launching an instance. And ignoring the console, this is using PowerShell to launch some instances. And you can see some of the key terms or the key parameters that I passed into this command. So new EC2 instances, I'm firing an image. So it's a certain AMI I'm launching from. I'm asking this instance to be started with my key. And that's my key pair name that I've got. And I've downloaded the private key portion of that. It's going to go into a security group, and this time referenced by ID. So the ID of the security group that, for example, enables port 80 to be accessed on this box. And an instance type, I'm going to launch a T1 micro, and this is a API name for a micro size instance. So PowerShell there is an example of launching an instance. Just as easily on Linux, I could be using our CLI tools, and I would be using EC2 run instances from the shell. Again, the AMI that I'm launching from, in this case I've added an instance count or something slightly different, a group, the security group, this time by logical name, web servers, the key pair I'm going to use, and the instance type I want to launch. So I can launch instances from a scripting language on Windows and Linux with ease, and it's very powerful, and there's a number of options, and if you download and install the tools you'll see how that works with a help command. You can also do this wrapped from SDKs. So here I've got Python Botto, which is an Amazon maintained Python library. So I'm importing Botto EC2 library, I'm connecting to a region, in this case US East, then I'm using that connection object to run instances. In the same way I'm launching from an AMI, passing in my key pair that I want to insert into the running instance. I'm using an M1 small, and I'm assigning the security group web servers to this running instance. And that will go off and launch an instance, and all three of those examples, they'll all pop up in the console as regular instances, and I can get on and use them. But what if you want to use those tools? Okay, so I mentioned that there are CLI tools, and there's Python Botto, there's PowerShell. Well, here's a really good tip that brings together some of the things I've mentioned, and it's called IAM Roles and the EC2 tools. So when you create something called an Identity and Access Management role, when you launch an EC2 instance in the wizard, you can select that role. So here I'm shown sort of an IAM role that I've called AWS Tools, and it's a little drop down that you'll find in the wizard for launching an EC2 instance. And on the right I'm showing a couple of screens from the Create Role wizard within the IAM tab of the console. And I've chosen actually the top one, which is an Amazon EC2 service role, which allows EC2 instances to call AWS services on your behalf. And it effectively puts a policy, shown below, against this instance, which allows it to not do any resource allocation at IAM, so not change any roles, but this instance is actually allowed to access anything within AWS, okay, any of the APIs. So it's a very open rule. Now you can obviously lock that down. The point is that when I launch that instance, and I'm launching it from an Amazon maintained Linux instance or an Amazon Windows instance AMI, all the tools will be installed and configured on that instance already. And then what will happen is that policy will then ensure that your secret access keys and access key and secret key are maintained dynamically and rotated on that box. Because when you set up your tools on your own machine, for example, and you download them, you need to configure things like your secret key so that we can authenticate against the API. Whereas if you launch an EC2 instance under an IAM role, all of that is taken care for you. If you need to revoke access to that, you can simply change the policy and say disallow every resource, and will automatically stop that instance being able to use any of the tools. So this means you can get up and running in a minute or two, and then you can just set SSH on or RDP on, and you can be diving into the PowerShell tools, you can be using S3 APIs, EC2, launch instances, and so on. And when you're done with that environment, just stop it or terminate it, because it's very easy to create a new one. But stopping it means you've always got a little launch pad that's secure for you to use the tools, and that's loads easier than maintaining tools on your own machines, and it's a great way of getting started with these tools. So great tip. So now you have the tools. Once you've done that, and you can do that in a couple of minutes, try this. So here I'm running an instance just based upon the AMI, and I'm saying launch one of them. Okay, so there's a few things missing there, or it looks like there is. So what about all this? So the group of web servers for security, the key pair I'm going to use, and the instance type that I want to launch. Well, there's a few things that are defaulted when you do a launch instance. Okay, so for example, the security group will go to the default security group, and there's always a default security group in a region. The instance type will default to an M1 small instance type, but the key will default to none. So what about the key? Well, instances don't actually need key pairs. Okay, so actually in a highly secure environment, if you're thinking about EC2 up front and how you deploy this stuff, you don't actually want people logging onto your production instances or any instance in the cloud, ideally. You want it to be completely locked down. But that begs the question, and how do you configure that instance if you can't log onto it? How do you bootstrap it? How do you get it to install software? There's a number of tools that we've got in the toolbox that enable you to do that. And again, this is feeding into the idea that your compute resource can come and go. And if you embody some of these principles and you get this right, you'll have an automated architecture in how you deploy stuff and get things without any fingers touching. So, bootstrapping, baking an AMI. So there's two ways you can do bootstrapping. First off is that you can bake software into the Amazon machine image. So you would start an instance, you would configure that instance by logging onto it, you would install some software, you would then configure that software, and then you would create an AMI from your instance. So you would then come up with an AMI in your account that's configured the way you want it. And then you can just simply pass that AMI ID into starting new instances. Versus configuring an instance dynamically. So this is where we could launch an instance and would use something called the metadata service and some associated technologies that are embedded in EC2 instances, like Amazon Linux has Cloud in it, and there's EC2 config on Windows, and we'll talk about how those work in a moment, to perform actions on those instances when it launches. So you might choose to install a web server, configure IIS, install or download some software code to run a website, for example, in a simple example. So there's two kind of approaches there, how much you bake into an AMI versus how much you configure dynamically. And actually, the real way of thinking about this is a combination of the two and a balance between the two. So the first is to bake your AMI and build your base image and set up some maybe custom initialization scripts that you need to run on your server. So these might be things that react to data you pass into it dynamically at launch time. You might set up different types of security setup on that machine, certain patch levels that you're comfortable with running at an OS level within your environment, and ultimately maintain your golden base. So this becomes your base for running different things. Then, configuring that instance type dynamically when you launch from that AMI, you'd use bootstrapping to pass custom information in, perform some sort of post-launch task like pulling code from SVN, installing different types of software packages, maybe configuring environment variables so that this server behaves as a production server versus a dev test server, for example. And that'd be the balance between the two that you need to get right. So if you think about baking an AMI, think about the constraints you have and how fast you want to start an instance up. So the sorts of things you would bake would be maybe something that's time consuming. So something that you don't want to take up too much time when the instance starts, bake it into the AMI because it's already done. So think startup times, things that are going to take a long time. Maybe doing yum update on a Linux instance to update all your packages is probably not the thing to do every time when you launch an instance dynamically. Do it once and maintain your golden base. Also, things that are more static, so that mean that you don't have to manage your AMIs all the time. So things that are going to change less often, bake into an AMI. Versus moving towards the right on this sort of balance is that, things like your latest code, if you're doing continuous deployment, or environment-specific properties that need to be configured as an instance comes up, these should be done dynamically via bootstrapping. So you're talking about finding the right balance between baking an AMI and minimizing your management overhead versus configuring something dynamically. So the goal is, ultimately, to bring up an instance in a useful state, and that balance will vary depending upon your application. But you want to think about instances coming up, asking where they are, what they should be configured to do, configuring themselves, and then getting on with the job. And that you shouldn't need to access that machine or SSH onto that machine ever. And hence, doing it without a key pair is a great way of ensuring that you're coming from a highly secure standpoint, and you're already engendering the philosophy of disposable compute, because if that machine goes wrong, the right thing to do is to destroy it and then recreate it via command to come from fresh once again. So the services that enable you to do that is that when you pass in something called user data, it can be a file, it can be a reference to file, it can be a piece of text. You could, in your request as a property, whether it be in the console or whether it be by a command or an API, that user data is passed to a known endpoint in a region, and it's called the metadata service. And every region, the same address, IP address within that region, has the metadata service. And an instance that's launching can get a whole bunch of information about itself from the metadata service. And some of those things, obviously, are the user data you passed in. So the custom data that we've passed in at launch time. So when an instance comes up, that user data is then passed to the instance. And depending upon a Windows or Linux instance, there's a different type of setup on that instance that will receive that data and do something with it. And now you can, of course, add your own custom ways of managing this. And there's great examples on our website about passing in different types of CSV or fixed length file format type data into user data and having custom scripts interpret it. But there's a great property of the standard setup that enables you to execute a bash script on launch. So if you were to pass this in, simply this chunk of text as part of user data to a launch request in the console to an Amazon Linux instance, this would install Apache, MySQL, tools, and PHP. So it would enable this as a web server that could run PHP and that could talk to a MySQL database. It would turn Apache on, and it would ensure that it was set as a service, so it was always running at launch. So as this instance comes up, it will install this software and be running a web server automatically. On Windows, it's something called EC2 config service that's running on our distributions that does a similar job for user data. So you could pass anything that you could do at a command prompt there in the script tags. If you passed in PowerShell, you can do anything that can run within a PowerShell tag. So this is a similar task of doing a bash script on Linux. Now, if you've used IAM Roles to launch this instance, and this instance is therefore authorized to use services such as S3 as part of its launch, then you can do anything that you can do in the PowerShell tools. So there I'm passing in to a Windows instance, reading from S3, a bucket from S3, downloading a zip file and sticking it into a local file on the C drive of this instance as it comes up. So you can bootstrap Windows and Linux instances, and if you combine that with IAM Roles, you've got a really powerful tool for doing all sorts of custom actions as an instance comes up. So IAM Roles and bootstrapping are your friends. So why do all of this, really? And just trying to sort of bring your head above water, really, and to sort of understand the reasons behind this, is that automation, less fingers involved means less mistakes, means you can take out a lot of the guesswork in how you got to a configuration or environment. So always a good thing to do. Security, your instances will be locked down by default. If you don't have keys on them and you don't need people to access them to configure them, then you're going to be in a better position. You're going to have a better security stance by default. Higher availability, because you can spin up multiple identical copies, you can spread across multiple availability zones. You can use these constructs to drive auto-healing, because if an instance fails, you just simply blow it away and you recreate it, and you can drive that in a number of ways within AWS. It's flexible. You can use Shell, PowerShell, CloudFormation, Chef, Puppet, OpsWorks, a new framework. So you can really do anything you like in terms of the bootstrapping and bring these instances up to be very useful from the off without any sort of complex configuration by hand. It's efficient because you can manage your state with less time and effort, and this is a way that you can scale, because without using this sort of philosophy behind managing a large-scale EC2 fleet, it becomes a very, very hard task to manage an auto-scaling or a very large-scale application workload. So some do's and don'ts though. So do use IAM roles. Go keyless if you can, because that engenders a better security stance. And then strike a balance between the AMI and dynamic bootstrapping, how much you bake in the AMI and how much you do dynamically. But the don't is don't put those API access keys into your code or bake them into AMIs and then share them. So don't publish code to Git that's got your secret key and your access key. So think about the IAM way of doing things is that your code doesn't need to have embedded keys to use things like S3 APIs. It can receive those because the instance will launch with an IAM role, and they'll all be properties within the environment that you're running in, and you just read them in your code dynamically. So don't publish those keys because they are keys to your front door and your account. So below EC2 then, so that's EC2, and that's a really core part of what we do in terms of bootstrapping and AMIs, and hopefully I've drilled into that enough to get you thinking about how you do that. The next thing to understand in EC2 is the different types of block storage that we have. We have instance storage and we have elastic block store. So instance storage is essentially local on host within our physical host within the AWS environment disk volumes, and the data on those disks is dependent upon the instance lifecycle, versus elastic block store, which are network attached volumes, and the data is independent of the instance lifecycle. So let's drill into those two things so you've got an absolute clarity on the difference and how you might use them. So if you look at instance storage, here is two physical hosts within our data centers, so host 1 and host 2, and on those hosts are a number of instances, A, B, C, D, E, and F. And on those hosts there was some physical storage, so directly within that host. And there I'm showing the instance stores, ethereal 0 through to 3 on each of those. Now each of those instances, when they start, can have a portion of that local host storage, which is opposed to EBS storage, which would be attached across a network somewhere else. So that instance store has a certain life cycle associated with it that you need to be aware of if you use it. So if an instance reboots, whether you choose to reboot it or it reboots unintentionally, then the instance store is preserved, it persists, so it's okay. However, if anything fails on that physical layer, you'll lose the data. If you stop an instance of instance storage, it will go. And if you terminate the instance, that data will be lost. So it survives a reboot, but pretty much all other conditions, that data is volatile. Okay, you need to think about different ways of dealing with that data. So different instance storage on different instance types has different flavors. So these are all the types of instances, their API names, and then the storage volumes that you can get for instance storage. Now draw your attention to one just to highlight as an example. So here a high IO, a high 1, 4 extra large, has two 1 terabyte SSD drives on that local instance storage, so on physical host. So when you start that instance, you'll get two of those SSD very high performance local drives to use. Now, if you think about the sorts of storage you can get in this way, certain workloads might lead you to use this stuff. So you might be running distributed NoSQL data stores, where actually what you want to do is to have lots of local caches on local disk, very high performance disk, because you can reconstitute those slices or shards of data in that cluster if it's ever lost. But if you were running a database, you wouldn't necessarily want to run on a local disk, because if it stops for whatever reason or the drive fails, then you will have lost the data. So that's where you start thinking about elastic block store. So elastic block store is network attached, and it's optimized network attached storage, so high performance storage, and you can have very high IO rates because we've got dedicated different types of network access to these drive volumes. But if you look at the diagram on the left here, there's sort of major components of what's going on. So in the VM workspace under the hypervisor, I'm showing those temporary instance storage disks inside the VM workspace, and then we have EBS to the right, which is network attached, and then on the far right we have S3 holding EBS snapshots, so the backup images. So have a look at a life cycle around this. We have, when you launch an instance, what we're going to do is we're going to create the VM workspace. So this creates all that ephemeral instance storage depending upon the instance types, and you get the workspace available then for an OS to be launched into. We take an EBS snapshot from S3 for the given backed AMIs that you're going to launch. We'll create an EBS volume, and then we'll boot the workspace instance from it. So we'll attach it to the hypervisor, attach across the network, and then launch your EC2 instance. And EBS is optimized for very fast startup time, very high bursts of I/O, in order to ensure that instances come up really fast. So EBS volumes will always be quicker to boot from than anything else. So that's kind of the life cycle around a boot cycle. And if you think about the EBS persistence cycle, you only pay for a volume as long as the data persists. So if you've got a volume of 10 gig, you'll pay for 10 gig for as long as that volume exists in your account. And there are two different life cycles that you should be aware of. So if you attach an EBS volume that you create to an already running instance, it will automatically detach from that instance with the data intact if you terminate your instance. So start an instance, take an EBS volume with some data on it, attach it to that instance, and then you blow the instance away, that volume will persist. But by default, just be aware of this, is that if the instance volumes that are created at launch time are deleted if you terminate it. So those original instances. But you can change that behavior by changing a delete on termination flag or termination protection as it's shown in the console. So if you flick that and you terminate your instance, your volumes will persist, and then you can use those volumes to launch a new instance in the event of a problem. So persistent lifecycle that's independent of the instance lifecycle if you so choose to leverage it. So that's disk drives. And then next up, then we talk about load balancing, and there's load balancing and auto-scaling will be sort of the last two elements of this webinar, because now you've got an instance running, you've understood how to bootstrap it. You're essentially spreading EC2 instances thin now, so you've got multiple instances, you've got a distributed architecture. Load balancing becomes the next thing you're going to need to implement. So it's a regional service. It load balances across availability zones. So what will happen is that when you launch an elastic load balancer, you'll effectively get an endpoint at the region, and then within each availability zone where you're running instances, you'll actually get a footprint of the load balancer. A piece of software will go into that availability zone, and it will front the instances in that availability zone. So it's a distributed software framework that is high availability and is elastic by nature. So you can spread instances across AZs, availability zones, and front them with an ELB. You can do the spreading that I talked about, so you can balance your resources across AZs. So we would say go small with your instance types and go wide. That gives you high availability and it gives you more granular control over scale and cost. Offload, so ELB does SSL processing, so remove SSL, do HTTPS in, and then get AT coming out the back of the ELB, upload your certs. Great way of offloading and therefore reducing the load on back-end resources. And then health checking is something to think about here, because you can choose where the ELB is going to ping to get response code back about the health of some underlying resources. So it could be the front page on your website that you're running, but it could be some other page that you're generating at some back end, which is coalescing the state of various tiers down below. Then you can choose to take out an entire section of your architecture by health checking the right point, because what we'll do as an ELB lever is that the health check fails from the rules you define, we'll take out that initial egress point for that particular section of your architecture. So check a whole layer is a good idea with health checking. Some tips on using ELB. So if you enable persistent HTTP connections on your backend server, then the connection between your ELB and the server will be optimized. You get a performance gain out of that. You get given a DNS name for an ELB. Never go and look for the underlying IP address, because actually there's a set of those behind an ELB, and real clients spread across all parts of the globe that might be accessing your service will be returning different DNS sets to get at that ELB, and they'll also change over time, because as the ELB scales or scales out and scales behind or scales down, then you'll get different sets of IP, so they will change. Other common mistake is that if you span an ELB across all availability zones, you get to choose whether it spans or not. Then make sure you have an instance in all availability zones, because otherwise you might end up drop connections or will have increased latency as connections are routed from an ELB endpoint in an availability zone where there are no instances available to take the request. And a way of common thing also is that people tend to terminate instances before they deregister from the ELB. If you deregister the instance from the ELB first and then terminate, you'll find that the traffic is routed to the existing healthy instances much quicker, and we won't have to do any of the health checking processes. Another thing I'm just showing here is that I've got Trusted Advisor, and everybody on this webinar for the month of March can access Trusted Advisor, which is our support tool. So if you go to the support tab in the console, if you go to help and support, you'll be taken to a dashboard view like this. And I'm showing here that I have my ELBs unbalanced. So I have EC2 availability zone balance warning here, saying that I don't have instances in all the availability zones that I'm running an ELB across the top of. And that's a bad idea. So typically it's best to have an instance in all three availability zones in EU, for example, if I'm running a load balancer across the top, maximize my availability. there's a whole bunch of other checks in here that will automatically look at security groups that we looked at, cost optimizing in terms of instance utilization, performance, a whole range of things, and you can go and check that now. So for the whole month of March, typically you'd have to be on a business or an enterprise support package to get this, but we're offering it open to everyone so that they can take heed of the actions that it's suggesting. Loads and loads of checks, a great place to have a look around and find out what's going on inside your AWS account. Autoscaling then, so the last piece then, so just in the last 5 minutes here, so automate the EC2 commissioning and decommissioning cycle, really. So when we talk about autoscaling, there are three main things to be aware of. The first is on the left here is a launch config. So recalling back those API examples, recalling back what we did in the console, we are choosing an AMI, an instance type, a security group, and an instance key pair, which will just be launched when autoscaling needs to do something, when it needs to launch an instance. And that config is something you can modify and change. So that's the base information required by autoscaling to operate. Then you create a group, which is basically the logical construct of the managed resources. It can automatically integrate with an ELB, and you're effectively setting a policy of like minimum or maximum desired number of instances. So you could have min 3, max 9, and you'll be running in EUS, for example, and you could go between 1 and 3 instances in each of the availability zones, for example, behind an ELB. And then you set policies. So this is what drives the action. So this will drive dynamic changes in a number of EC2 resources. And if you've got your AMI baked and if you've got your bootstrapping right, then instances can come and go, and they'll be useful immediately as they come into service when autoscaling takes effect. So creating a launch config at the CLI tools, AS create launch config, you can see there's the usual suspects there that I need to define what's going on. The addition of a launch config name. So this is my definition of the instance I want to launch. You then create an autoscaling group. And in this case, I'm actually configuring it to talk what's going to launch, my launch config, but also to integrate with an ELB. Now, autoscaling doesn't have to be integrated with an ELB. It could just be a group of resources that's driven off queue depth, for example, a number of messages in a queue. If it gets deeper, add more resources. But I'm integrating it with my Elastic Load Balancer, and I'm setting a min 1, max 5 pool of resources. And then I create two things, a policy to scale up, which is an adjustment of 1 here, and a cooldown of 300. So nothing else will happen for 300 seconds, because what we don't want to do is to scale up and scale down, scale up and scale down repeatedly. What we want to do is dampen the process. So this is acting as a damper of 300 seconds before some other event can kick in. And then likewise a scale down here, I've got an adjustment of -1. And if I apply all of those with our auto-scaling tools, I can then tie it all together with something called CloudWatch. So CloudWatch is a monitoring framework that you can get a whole bunch of stats from. So you can go into your EC2, your ELB, your RDSs, whatever it happens to be, hundreds of different metrics that you can collect, and you can configure alarms against those. And it's alarms that will drive proactive action. In this case, will drive things like autoscaling. So if you look at, for example, aggregated across instances here, CPU utilization, I can drill into charts and graphs. And if I set thresholds on this, and that will trigger my alarm. I can have thresholds that are going above a particular point, triggering alarm, and then triggering out of alarm state when I go below. And that's what will trigger a scale up or a scale down activity. So if you think about that, a CloudWatch alarm, CPU greater than 50% for 5 minutes, then scale up. CPU less than 30% for 10 minutes, then scale down. And you can do that in the console, for example, when you set an alarm. If you've defined those auto-scaling policies that I showed you before, an alarm state is alarm, take action, auto-scaling policy, on an auto-scaling group, and enact which policy, which is the scale-up policy. And those are things that were created by those command line tools that I showed you before. And you can do that yourself, and then you'll be able to go into the console and knit together a scaling action. Likewise, you might take some other actions. You don't have to trigger auto-scaling. You could do additional actions via simple notification service. So you might deliver a message to an SQS queue, post to an HTTP endpoint, or send an email. And just to show you how that sort of stacks up, you would create a subscription in SNS, and here I can show my drop down of the different types of things I can send to. So this is a subscription to a topic, and then when the alarm state is in alarm, you can see my CloudWatch action is to send a notification to my test topic. And that could be to send an email to me, or as I said, it could be to drop some JSON in an email, or JSON on SQSQ, which describes the event. And I can then programmatically take effect on that, or I can simply have the notification that an auto-scaling action has happened in addition to actually auto-scaling taking place. So CloudWatch is a way of knitting all that together. So it's comprehensive in terms of the billing alerts you can get from it, the technical alerts, you can aggregate stats, you can fire in custom metrics as well. So you could write your own metrics in the SDKs, push them into CloudWatch and use that to drive SNS or drive auto-scaling. As I said, it integrates with SNS, HTTP, you can poke HTTP endpoints, custom points in your application, send emails, or just generally set a whole bunch of alarms, whether it be that you spent $10 on your account, or whether it be your EC2 instances have got to a certain level of CPU utilization or what have you. Okay, so closing off, I'm slightly over my 45 minutes, but other topics to look at. So EC2 bridges you out into a whole bunch of different areas, and some of the things that you should take a look at outside of this webinar is resource tagging, because you can set key value pairs on your resources like EC2 instances when you launch them, and then they'll flow through onto billing reports so you know what part of your bill is coming from what resources. Have a look at Route 53, so fronting EC2 and ELBs with Route 53 DNS provider gives you some extended different types of record sets which give you great control over DNS, and allows you to do things like rolling deployments as well, so you can use Route 53 and ELBs to do A/B testing or spin up whole replica environments and just swing load slowly across onto your new applications in EC2 and back again if they don't work. So rolling deployments is a great way of using those things in combination with EC2. And then there are management frameworks as well. So there are Beanstalk for managing an entire stack, such as Ruby or Python. So popular container that will do an auto-scaling app. There's OpsWorks, which is a really new tool set which relies on chef recipes to automate all that configuration of EC2 and auto-scaling that I've talked about. And then there's CloudFormation that goes to the nth level of degree of detail on configuring everything from a CloudWatch metric, an SMS topic, what's YUM installed on an EC2 instance, EBS volumes at launch time, and so on and so forth. So really granular stuff on CloudFormation. So in summary, stop doing these things really. Stop hugging the server, as Werner Vogels will say, but stop provisioning and fixing servers, treating compute as physical things, or thinking of compute as this finite commitment. You've committed to this instance type or this compute and I must use it. Think about it as something you can flip and change and it can come and go, because you'll start doing elastic applications, you'll start thinking about automation, you'll have more secure systems by default because of that approach. You'll be replacing things, not fixing them, so you can auto-heal things at 3 AM in the morning, and then at 9 AM when you're in the office you can work out what went wrong. You can be unconstrained, so you won't have to do traditional capacity planning anymore, and you can be cost aware too, so you can know exactly what resources are costing what in your environment, and you can play with the instance types. So start doing those things. And if you want to see a video, I've put a video up on YouTube of going from an empty account all the way through to an auto-scaling application. So taking into account all that bootstrapping type aspects that I've talked about, baking AMIs, ELBs, auto-scaling, and I introduce things like RDS too. So you can go to that URL. And as always, you can find out more at aws.amazon.com. So thank you very much for listening.